has come. We're done with new stuff. The course is over in a sense. Now it's review stuff. You've had Trig, right? Maybe it's been a while though, or maybe it wasn't such a good experience, or it's just been so long. So we're going to review. We'll start from the ground floor. Most people do really well on the Trig part of this course just because you've seen at least some of it before, and I'll review from the ground floor up. So it's kind of nice that way. So the exam that we'll take, exam 4, which is whatever that is, 2 weeks from now? All right, yeah, week after next, right? Yeah, Monday, yeah. 2 weeks from today, we'll be finishing it up. So anyway, that one will have section 6.2 and 6.3. So Trig, this Trig will be on exam 4, and one more section of Trig will be on exam 4. And then the rest of the Trig, we do some more Trig, 6.4, 7.1, 8.1, those will be on the final. So it's Trig the rest of the way now. And the way it's going to go is we'll do things like this, and we'll do them without our calculator. So let's take a look here. So they're giving me a unit circle, and they're telling me a point P on the unit circle. Let me make it a little bigger so we can see it a little better. So there's a unit circle. There's some point P over here. And the coordinates of that point are root 3 over 2, comma, half. So that's the coordinates, the xy coordinates of that point on the graph. The x is always the cosine. The y is always the sine. Do you remember that from your trig days? So yes, that's almost the most important fact. So the x, whenever you're on the unit circle. Now when I say unit circle, that's the one I handed you. What is unit circle? What does that mean? Unit. What's the word unit? It means 1. Radius 1 circle. Everybody get one of these? Go on. Radius 1 circle. So this is the unit circle, the circle whose radius is 1, the distance to the edge is 1. So about halfway through the section, we might not get to that till tomorrow, but about halfway through they'll put up bigger circles, and it won't be radius 1, so things will change a little bit then. But for now, what I handed you, what they're going to ask us about is all unit circles. When you're a dot on the unit circle at some angle t, this is some angle here, some opening, some angle. You start, the flat is 0. This is 0 right here. So you start at 0, you start right there, and then you open up to whatever angle. And when you do, and you have a point on the unit circle, the x coordinate of that point is the cosine of the angle, and the y coordinate is the sine of that angle. So they give me that, and they say, okay, what's the sine of the angle t? Well, it's right there. It's the half. It's just the y coordinate. What's the cosine of the angle t? Well, it's just the x coordinate, the root 3 over 2. Okay, what's the tangent? Does anybody remember what tangent? Yeah, tangent. It might be helpful. Let me go over to a fresh screen here and just write out the definitions for it for you. The sine is the y coordinate. Well, you know what it is? Maybe it'd be good if I gave you the official. Technically, the sine is y over the radius r, and cosine is x over the radius r. Yeah. But on the unit circle, radius is just 1. So this just becomes y, and this just becomes x. When you're on the unit circle, which we're going to be like 95% of the time. Right near the end of this section, they'll put us on a bigger circle where the radius isn't 1, and then we'll have to remember, okay, yeah, really sine is not y, it's y over r, and we'll have to stick it in the r. But 95% of the time we're on the unit circle, radius 1. That's why we do that, because that just makes it easy. Radius 1, and so sine is just the y coordinate, cosine is just the x coordinate. Tangent, yeah, just like Alex was saying, is sine over cosine. So, and then, remember how to get the other 3 trig functions? Flip them, flip them, flip them. Exactly. So cosecant is upside down of sine, and secant is upside down of cosine, and cotangent is upside down of tangent. So good idea just to put that right on your 3x5 card for the next exam, unless you already know them pretty well. So there's the definition for the 6 trig functions. So let's go back then and figure those out. So coming back over here. So tangent, sine over cosine. So that would be sine a half over cosine root 3 over 2, half over root 3 over 2. And so you know what to do when you have fractions over fractions. You grab that one on the bottom and flip it up. Flip it up. 2 over root 3. Like that. And these 2's cancel. And you get 1 over root 3. And then, you know, you can't leave a root on the bottom, right? So you just multiply top and bottom by root 3. And you get root 3 over plane 3. Right, because root 3 makes plane 3 in the bottom. Right, 2 root 3's make a plane 3 in the bottom. All right, so there's tangent. Now let's get the other 3 trig functions. The, what is it? Cosecant. Cosecant, that's going to be 1 over the sine. So 1 over a half. Flip that up, 2 over 1, 2. Cosecant's 2. And then upside down from cosine would be secant. So flip that over. So you're going to get 2 over root 3. I just flipped the cosine upside down there. And can't leave a root in the bottom. So multiply by root 3 over root 3. What do we get? 2 root 3 over plane 3. Like it. And then finally, cotan, which is tangent, flip it, 3 over root 3. Can't leave a root in the bottom. Multiply top and bottom by root 3. That's 3 root 3. And root 3 is plane 3. They cancel. Root 3. Good, I got all 6 trig functions there. Do you remember that from previous stuff? Questions I can answer. We're starting ground floor, though, so we're not assuming any knowledge. And those are the basic, fundamental definitions of sine, cosine, tangent, cosecant, secant, cotan. So again, sine, let's go back to maybe this page. Sine is y over r, and when r is 1, on the unit circle, that's just y. And cosine is x over r, but when r is 1 on the unit circle, that's just x. So fundamentally, sine is the y-coordinate, cosine is the x-coordinate, and then all the other 4 trig functions just are made out of sine and cosine, aren't they? Really, all of trig is sine and cosine. The other 4 are Johnny-come-latelys. They're just made out of sine and cosine, aren't they? It's all about sine and cosine. All of trig is about sine and cosine. Is that good? I don't want to go too fast over the first one. Make sure your fundamentals are good. Questions on that? Okay. Okay, so you all have your unit circle, right? That I handed you. Like that right there? You'll have that. Everybody get one of those? Everybody came in? There's one up in the front table. I don't know if anybody else came in. Okay, so let's go back to the question. So tangent of 6 pi. Where is 6 pi? If you look at the unit circle, there's no 6 pi. Here's 2 pi right there, which means it's all the way around. Yeah, 6 pi is all the way around 3 times. Does everybody see that? So remember, again, you start here at 0. This is 0. You start here, right? You start at 0. This angle is 0 degrees. And you go all the way around, and that's 2 pi, or 360. See, I like this unit circle I got off the internet because it has both the radians and the angles. This would be my suggestion to put this on your... I'd make one whole side of my 3x5 card, probably. This, exactly, for the next exam. So anyway, so one way around is 2 pi. So if you go all the way around a second time, that's 4 pi, 2 pi and 2 pi. And you go all the way around a third time, that'll be 6 pi, 2 pi plus 2 pi plus 2 pi. So really, when they say, find where 6 pi is, well, it's right here at the start, isn't it? Because you've gone all the way around completely, exactly 3 times. So you end up where you started for 6 pi. And, okay, so what? Well, what are the coordinates there? Well, it's 1, 0, which means the x is cosine. Remember the definition of cosine is just x? And the y is the sine. So that's the most fundamental thing to remember. Whenever you end up at some spot on the unit circle, the first one is cosine, the x is cosine, the y is sine. So what do they want from me? They want tangent. Let's go back. So on the unit circle, we end up right here. And what's the coordinates Like graphing, just normal graphing. What are the coordinates of that point? Well, that's the point over 1 up 0, isn't it? And this is the cosine, and this is the sine at 6 pi, which is all the way around 3 times, so it's nowhere, really. So there it is at 6 pi. So what do they want, tangent? So tangent, the definition is sine over cosine, like that. And so what is sine of 6 pi? 0. Cosine is 1. 0 over 1 is 0. So that's how we do that without our calculator. Is that making sense? And so, yeah, let's leave it at that. Well, yeah, let me say, that's the way it'll be on the exam we take December 4th, 5th. Part 1 will be no calculator, and mostly what will be there is trig. So all of these trig things I want you to be able to do without a calculator, but you can have your unit circle, you know, on your note cards. You don't have to memorize them all or anything, but I just want you to physically use that unit circle because you really want to get that idea in your mind for calculus. If you're going to calculus, it prepares you well. Because in calculus, they won't just be set locations, they'll be moving. There'll be limits, and the angles will be moving. So you have to really understand the flow, that it's you know, position as it travels around the unit circle to get the idea of limits down well. So that's why I'm into that and going to require that. So you can't just push the buttons. There'll be, you know, these questions will be no on the first part, which is actually no calculator, not just no graphing, no calculator at all, just like exam 3 was, right? Part 1 will be no calculator at all for these trig questions, but you'll have your unit circle. All right. So sine of negative pi over 2. All right. You know what I usually do? Well, that pi thing, remember that's radians? Remember that whole there's radian angles and there's degree angles? I don't think naturally very well in radians, so I always just convert. You don't have to. If you're good with radians, you can just keep it in radians. I'm just going to convert right away. Remember how to convert to degrees? Remember what pi is?
Pi is 180.
Pi is 180. Yeah, if you look back at the unit circle, see pi right here? It's at 180. Pi is 180. Pi radians is 180. So when you see the pi, I just always stick 180 in the place of pi. So you get sine of negative 180 over 2. Pi is 180. And so that's sine of minus 90. Right, good. Now we're ready to go to the unit circle and find negative 90. Now, here, let me get a fresh unit circle. So where is negative 9? I don't see any negative angles. This one I got off the internet here.
270.
Yeah. Remember, so here's 0. We start here at the flat 0. So this is 0. Positive angles go up 30, 45, 60, 90, 120. You know, they get bigger and bigger and bigger going up. So therefore they're negative going down, aren't they? So if you have negative angles, that means down. So negative 90, that's straight down, isn't it? Everybody good with that? Negative 90, because this is 90 degrees, right? Straight down. So negative 90 is straight down 90 degrees. So here's the x and the y. So this is cosine. This is sine. There, it's this point right here. So all you do is all you're going to have to do on the exam is just simply, you know, we're saying, okay, you want the sine of negative 90? So I go to my unit circle, find the point down here. What's the coordinates? What's the graph? If you were to graph that point, over 0 down 1. Now that's all the unit circle is saying to you. It's saying at 270, which is the same as negative 90, it's over 0 down 1. And we know the cosine is always the x, and the sine is always the y. So this is cosine, this is sine. What do they want? They want sine, negative 1. They don't even want the cosine at all. Is that good? Questions I can answer on that? That's not too bad, right? Okay, so try that. Go ahead and use your unit circle that you've got. Find the 60-degree angle and grab the, you have the two numbers there, the x, y. Remember, the x is the cosine. The y is the sine. So grab the x, grab the cosine of 60, and then go to the 45 and grab the sine, the y value. See if you can add them up. So when we go to, what is it we're doing? A cosine 60, go to 60 degrees. 60 is right here. It's this point. So this is cosine. So they want the cosine of 60, a half. And then the sine of 45 is right here. Sine is the y, root 2 over 2. So those already have a common denominator, so you can just put them together in one fraction. There we go. That's the answer they want. They want an exact answer with radicals. They don't want a decimal thing at all. So that's just it. Luis?
What's the purpose of grabbing the cosine and the sine 45? Because I see we have a triangle that's 60 degrees and then a line that goes through it at 45. What purpose do we use that for, like, eventually? Why two different numbers? Two different degrees?
Oh, why are we like adding these two up right here?
Right.
Yeah, well later trig is used for all kinds of things. Am I answering your question? You mean
You're looking for a point on a specific graph.
right? Yeah, but that's just how you crank out the values. That's not what you do with them. So yeah, like what? Yeah. How about that? That's a good question. You guys, let me put it back on all of you. I like Luis's question. You guys had trig, right?
Mm-hmm.
What's it all for? You know, I would honestly have had no idea. If somebody had grabbed me off the street when I was taking all these math science classes and somebody had said, all right, what is the sine or the cosine? I would have said, I have no idea. I can crank them out. Give me an angle. I can find the cosine of 30. I can whatever. But like, what is it in the real world? I have no idea. That would have been my answer. So maybe you're where I was. It's circular functions. It's anything going up and down. That's what trig is really useful for. So basically, there's all kinds of things in the real world that go up and down, like the plugs in the walls there. Alternating current is coming out of those walls, which means it goes up and down like a sine curve. The 120 volts coming out of the wall isn't steady. It's not like a battery. Batteries are DC, direct current. They're steady, same voltage all the time, same current all the time. But the plugs in the walls, it rises and falls. It has a phase to it. So that's something that goes up and down. So when electricians, electrical engineers do stuff, or anybody does stuff with that kind of thing, they got to use trig, because trig is a made-up thing. Remember, all of math is made up. They just made up this thing. Why'd they make it up? Because there's all kinds of things in the real world that rise and fall, rise and fall. Tides with the oceans. All the planets, right? They're moving. You know, the orbits, the days and the weeks and the years. Things are rising and falling. The moon is going around, up and down, up and down. The ocean tides go in and out, in and out. All kinds of motions of different things in life. Wheels on a tire, automotive engineers, up and down, up and down. So anything that rises and falls in a repeating pattern, cyclical pattern like that. Trig, sine and cosine, are a way to model that behavior. So a sine function, what is the height? If I said, watch this dot as it goes around, what does this dot do? It goes down low, comes up high, the dot's here it's at the highest point, goes a little lower, here it's at a 0. Now it's negative, the dot's going down, dot's going back to 0, dot's going high, right? So the height, which is sine is the height of that dot, the height rises and falls, rises and falls. So anything in real life that rises and falls, you model it with a trig function. So trig is used to model anything in life that goes up and down, up and down. That's what they use it for. Now, they just use the circle with the values and the xy coordinates, because that's just an easy way to get the numbers. They made this up, too. This is just an easy way to get numbers, but it doesn't mean you have to have a circle. It only applies to circles or something. Anything in life that rises and falls, trig is used for. Yeah? Cyrus, did I answer your question? All right. All right, good question. All right, so there we go. Let's try another. Bless you. Okay, so try that one. 2 cotangent of 90. 2 cotan of 90 minus 7 cosine of 180. All right, so by the way, how are you going to do cotan of 90?
Over 10. 1 over 10.
Yeah, 1 over 10, huh? So this is going to be, cotan is 1 over 10. And really, you know, upside down of 10, how about this? I think it would be best to do cosine over sine. Does everybody see how I came up with that? Because remember tangent is sine over cosine, right? Cotan being upside down of that will therefore be cosine over sine, won't it? Cosine's upside down of, cotan's upside down of tan. So just, yeah, I would go, this is times here, 2 times cosine 90 over sine 90 minus 7 cos 180. So then I would go to that unit circle, find those values, and plug them in. All right, so then we go to unit circle, cosine 90 degrees. So here's 90. This is over 0, but cosine is the x, sine is the y. Cosine of 90 is 0. Good? So we say, okay, cosine of 90, so this is going to be 2 times 0 over, and sine of 90 is 1. Right, wasn't that 0 and 1? Yeah. 0 and 1. And a minus 7, and then cos of 180. Yeah, this is negative 1, 0. This point right here at 180. Cosine is x, sine is y. Cosine is negative 1. So cosine is negative 1. So what do we get? 2 times 0 over 1 minus 7 minus 1. That's 2 times 0. That's just 0 plus 7, 7. Is that making sense?
Maybe he doesn't respect it, so it could be that that's
You all good with that? That making sense? Questions I can answer? All is well? Okay, so try that one. 5 secant of pi over 3 plus 7 cotan of pi over 6. So use the unit circle. Got to remember what secant is, or look back to the definition of what secant is. So what is secant? 1 over cosine. Secant's the flip of cosines. 1 over cosine. And then cotan, we already just talked about him a minute ago. He's cosine over sine, right? Because he's upside down. Cotan. Did I say it wrong? Cotan is cosine over sine. So this becomes 5 times 1 over cosine plus 7 times cosine pi over 6 over sine pi over 6. Oh, yeah, because this is a radian, huh? Yeah, so it'd be good to do it. So they want sine. Let's start with sine. Sine. Well, actually, let's convert the angle. 5 pi over 6. Can you change that into a... well, I guess you don't need to. It has radians right on the chart, huh? Yeah, we'll just stick it. We'll just leave it as it is. All right, let's just use it as it is. So just look at the chart. 5 pi over 6. Where is that? So let's go back to the unit circle chart here. So find 5 pi over 6. The only thing, I looked at several unit circles online before I selected this one. I like everything about it. It's got the degrees, got the radians, got the values I want, the main 3 in every quadrant, not extra. Someone put a bunch of extra ones in. And it's got the, I like the positive, negative. It's telling you which functions are positive and negative and which quadrant it's writing. I think that's important. The all students take calculus. I don't know if you remember that. We'll talk about that next week probably. Anyway, the only thing I don't like about it is they made the negative signs too small. Like you can hardly tell that's negative there. And that really is important to not miss that little negative sign. They should have made those negatives bigger. Otherwise, I love their chart. So, all right, so watch out. So 5 pi over 6 is right here. That's negative root. So the cosine, the sine, negative root 3 over 2 is the cosine. We want the sine. Sine's a half. So where are we? Here it is. So sine's a half. Cosine of that spot is negative root 3 over 2. Right? That's the one I showed over here, isn't it? Yeah, I went to 150, didn't I? Got it a minute ago. Just went, hey, it's back a large amount, up a small amount. Back a large amount, up a small amount. Of course, it's back root 3 over 2 is the x coordinate, and up a little bit, up a half is the sine, of course. So there we go. There's sine and cosine. Now, how do you get the other 4 trig functions? It's just combos of these two, right? We all good with that? Just so tangent is just sine over cosine. So it goes a half over negative root 3 over 2. Flip that up. So it's a half times 2 over negative root 3. These cancel. That's a negative. I'm not making my negatives very good. 1 over negative root 3. Get rid of the root 3. This problem just keeps going on and on. Negative root 3 over 3. Whew. There's the tangent. And then for the other 3, flip it, right? For cosecant, secant, and cotan. I'm going to move on if that's okay. That good? So 510 degrees. What do you do when they give you a big angle like 510 degrees?
Just add it.
Subtract minus 360.
Yeah, is that what you meant? Just add from 360 or subtract 360. Either way, same thing. Yeah, you just subtract. What is that? Was it 150?
Yeah.
Yeah, 150. So really, that's the same as 150 degrees. Because 510, what that means is 510 is all the way around 360, and keep going 150 more where you stop. That's 510. So 510 is a full 360 and 150 more. In other words, it's the same thing as just asking 150. So when they say, what's the sine of 510? It's the same thing as them just saying, what's the sine of 150? Because it's the same spot. To go all the way around 360 and 150 more is the same thing as just going to 150. So I'm going to go dot, dot, dot. Now you just use the unit circle for 150, right? Find all the trig values on that. Put that in your 3x5 card. All right, so negative 30. Want to try that one? So find that on the unit circle. Wherever that is, I don't know. So find negative 30 on the unit circle. So where do you go for negative 30? Yeah, you go down 30 degrees. So 360 minus 30, you go to 330, don't you? Everybody good with that? Because negative angles are down. So here's the cosine, here's the sine. What do they want? They want them all, don't they? So root 3 over 2, negative a half. So we go back and go, okay, that's at 330, because we just basically take 360 minus the 30. So 330, and that's over root 3 over 2, down a half. Of course it is, because this is over a large amount, down a small amount, isn't it? It's over root 3 over 2, down a half. So there we go. This is the cosine, this is the sine, and away you go. You can get all 6 trig functions. Because it's all about sine and cosine. Once you have sine and cosine, the other 4 come from sine and cosine. Easy? Trig's not that bad, is it? It's all about sine and cosine. Okay, let's. So what do we do with 1170? Just keep subtracting 360, huh? Until you get something you can deal with. What was that, 810? Subtract 360 again. I don't know what that is. 450? Yeah, I think so. And then subtract 360 again. This is 90, huh? So it all just boils down to a 90-degree angle. 90-degree angle, I don't even need to look at the unit circle. I know where 90 is. That's straight up, huh? If 0 is here, 90 straight up. And what's the coordinates? If you were to graph, that dot is over how far, up how far? Over 0, up 1. So the cosine is 0, the sine is 1. You can do all 6 trig functions. Easy?
Yeah.
Of course, it gets a little easier at this point. Huh? So secant 61 degrees. Because how are we going to do that? We don't have a secant button on our calculator.
1 divided by cosine.
Yeah, it's 1 over cosine. Huh? Make sure you're in degree mode. Do you know how to do the modes on that? Every calculator is different, but if you have the TI, hit the mode button over on the to the top. Second over on the top. Yeah.
There's a cosine power of -1. Does that count as 1 over?
No, that's actually inverse cosine. We'll get to that next week. Yeah, that's not it. So cosine 61. So you go. So first of all, go to the mode. Hit the mode button on your calculator. Make sure that you are in degree mode. First off. So here's the mode button right on the top. If you have the TI, hit the mode button. Mode, and see that little screen that comes up? See how I'm in degree mode, not radian? See the third row down? It's radian or degree. Make sure you're in degree mode. If you're not, go on to degree and hit enter, highlight it, and then just quit that screen, and you'll be in degree mode. There's all your modes for everything. So yeah, so then just type it into your calculator. Just go 1 divided by cosine, because secant is 1 over cosine. 61, don't even need to close the parentheses. 2.06, how many places do I want? 2 places? Yeah, 2.06, y'all getting that? Okay on that? Questions? Good catch. All right, we good? All right. That was good hands, Erica, but in the game today, no hands. All right? Cotan, 7 pi over 19. What do we do when they give us that pi thing? Yeah, I would just, you could change to radian mode, and you could just do it, but I don't like fiddling with the mode. I would just put in a 180. That's what I do. Personally, I find that easier. So I would just go, and cotan, that's 1 over tan. Have a good game, Erica. Put on your game face before you get there.
Okay.
180 over 19, like that. That good? And just type that in your calculator. I'll do mine too. Divided by tangent.
How did you get the 180 degrees?
Pi is 180. Yeah, the pi, I just stick 180 in its place because pi radians is 180 degrees. That's always how we change. They're the same spot. I'm getting, here's what I did on my calculator, 0.44, 0.438, which they want 2 places of 0.44. What I did there, if you can read that a little bit. I don't know if the little light thing helps for better or worse. 1 over tangent, 7 times 180 divided by 19. I don't bother to close the parentheses. You don't need to. All right, whatever. There we go. So, good question. If you have any trouble with that, come see me. Be glad to help with calculator stuff. The calculator stuff's not working. Okay, the trick on this one is that is not on the unit circle. They're trying to trick us here. So 8, negative 3. There's no, if you drew like on a graph, like over 8 down 3, over 8 down 3, the point over 8 down 3. No way that's on the radius 1 circle. The radius 1 circle is, it's only radius 1. That goes 8 over, 3 down. It's well beyond the unit circle, huh? So because this dot is not on the edge somewhere of the unit circle, you can't just say, oh, the cosine is the x and the sine is the y. You can't do that. That's only when the dot is on the unit circle, radius 1 circle. So then how am I going to do sine and cosine and everything if I can't do that? Remember the definition I gave you a few minutes ago? Sine of any angle is not really just y, it's y over r. R is this right here. Got Pythagorean theorem. A squared plus b squared is c squared. You got to find the r. So let's make a little right triangle here. So 8 squared plus negative 3 squared is r squared. Everybody see that? Because, again, why? Because that's what coordinates mean. Like Luis was bringing up, that's exactly right. That's what coordinates mean. They mean straight over, straight down. That's what it means to be any rectangle. We call them rectangular coordinates because they make a rectangle. They go straight over, straight down, right? Well, and then you connect them. It makes a triangle there. So that's straight over 8, straight down negative 3. So that makes a right triangle, doesn't it? Because it's straight over, straight down. There's the radius of the triangle there. So 8 squared plus negative 3 squared is r squared. So that's 64 plus 9 is r squared. 73 is r squared. Root it. So r is the root of 73. So then the sine is not just the y-coordinate, it's the y-coordinate over the r, which we now know is square root of 73. And you can't leave a square root in the bottom, that whole thing. So multiply top and bottom by root 73, and you get minus 3 root 73. I'm messing up. Over plane 73. Everybody okay with that? All right, I multiply the two root 73s in the bottom. Got a plane 73. So there, and then that's just, they want the other, they want cosine and tangent, and you can get all the rest. Same kind of way. All you'd have to get is sine and cosine with the, because cosine would be x over r, wouldn't it? So it'd be the x value over root 73. Same thing, multiply top and bottom by root 73. 8 root 73 over plane 73. There's cosine. So it's sine and cosine. The other four trig functions just come from sine and cosine now. Once you got sine and cosine, you got it all. They're the key. You can unlock any door. Right? Yeah, Luis.
So is that the answer that we got for sine theta, is that the measure of the arc or just the angle?
What that is, that's the height at that spot. So in other words, it's it's the height where it hits on the unit circle. So in other words, let me draw a better picture. Well, I could do this picture. It'd be right here, because this is where the unit circle hits that, over 8, down 3. There's the over 8, down 3. Right? Here's where the unit circle hits that. It's this height right here. Sine is the y-coordinate to the spot on the unit circle. And cosine is the over to that spot on the unit circle. Now, when we divided basically these guys by root 73, which is the hypotenuse of this triangle, we effectively shrunk the triangle down to fit on the unit circle. That's what we did, because the radius is root 73. So when we divide these all by root 73, this radius becomes root 73 over root 73, 1. We shrunk it down. That's what we effectively did. We took the triangle and shrunk it down to fit right in here on the unit circle. And then the y over r is the height on the unit circle, to the point on the unit circle. This is shocking for me, so I'll do it then. All right, so I'll do what I can. This is a long, painful, terrible problem. So, same kind of thing, but it's just ugly with fractions. So they're giving me the x, they're giving me the y. You know the deal, that's not on the unit circle, so we got to do the whole thing. Pythagorean, so x squared plus y squared is r squared, right? Then we got to find r and divide the x over r for cosine, y over r for sine. Okay, but it's a pain. 136, 164 is r squared. Good so far? Now, how are we going to add those stinkers together? Yeah, it's a pain. I'm just going to multiply top and bottom of this one by 64. Top and bottom of that one by 36. I don't even know what 36 times 64 is. It is 2304. So that'll make 2304. This will be 64 times 1, 36 times 1. That's 100 over 2304. We good to there so far? So I added those up. And then root it. R equals, and that'll come out 10 over, I think, 48. And then reduce that, 5. Well, I can't write it there. My little iPad won't let me. So R is 10 over 48 divided by 2 top and bottom. 5/24. So R is 5/24. So we've got a radius. So now we can go back and say, okay, what's cosine? Or let's start with sine, I guess. What is sine of any angle? Y over r. So you got to take the y value, 1/8, divide it by the r. Flip that up, kind of go dot, dot, dot. You get the rest from there?
Yeah.
All the rest, now that we have r. A little bit of painful work there. All right.